In this video, we're going to work through some problems with various types of rates. And if you aren't familiar with the concept of a rate, I encourage you to go watch the video I made explaining what a rate is and how they are used, and I will link that in the top right hand corner of the screen. But otherwise, we will continue with an example problem. So let's say that we are told that a cyclist travels a distance of 90 miles, and he travels this distance in 6 hours. So we can write per 6, what's a G, per 6 hours. And we are asked to find the unit rate. And all the unit rate means is that we want to find the rate in which the time is going to be 1. So we want to find her average speed in a singular hour. So we need to find, let's write this as a ratio for this problem. So we can write this as 90 miles and then ratio 6 hours. Well, you're hours here. 6 hours. And in order to find the unit rate, or a rate in which the hours are equal to 1, there's 1 hour, we need to divide both parts of this ratio by 6. Because any number divided by itself is equal to 1, so if we divide the hours by 6, we will end up with 1 hour. 1 hour. 1 hour. And since we did that to this part of the ratio, we're going to need to do the same thing to the other part. So divide by 6. And this is 15, but we can go ahead and do the division just to make sure. So we have 6 into 90. 6 goes into 9 one time. Subtract. That's 3. Drop down this 0. 6 goes into 30 5 times. And then 6 times 30 is 5. So that is 0. And our answer is 15. So we travel 15 miles in 1 hour. And this unit rate will give us, let's say, for example, we want to know how many miles we traveled in 3 hours. We can multiply both by 3. Or we want to figure out how many hours it takes to travel 45 miles. And then we would multiply by 4. And then that we would find out that that's 4 hours, because 15 times 4 is 45, and so on and so forth. So you can see kind of how rates are really useful in everyday life. Let's move on to a new problem. So let's say we have a metal block, and I can attempt to draw this metal block. I can't promise it'll be that good, but we will try. So we'll draw a metal block. And let's say that we are told that this metal block has a mass of 500 grams. It's not the best block, but it'll do. 500 grams, 500 grams, and then it has a volume of 100, so we can write per 100 centimeters cubed, or cubic centimeters. And we want to know what is the density of the metal block in grams per 1 cubic centimeter. So in order to do this problem, we need to know the formula for density, which we can write. Density is just equal to an object's mass divided by its volume. And we want to know the density in 1 cubic centimeter. So we can rewrite this as a ratio. So we have 500 grams per 100 cubic centimeters. And then to get to 1 cubic centimeter, we are just going to divide by 100. We're going to divide by 100 here. Then we're going to do the same thing over here. Let's see. So 100 divided by 100 will be 1. So this will be 1 cubic centimeter. And then 500 divided by 100, well, that's the same thing as 5 divided by 1. That's just going to be equal to 5. So we have 5 grams, or we can just drop that as a G. And we want to know the density per cubic centimeter. So we take this formula up here. Our mass is 5 grams. 5 grams. And then the volume in 1 cubic centimeter is just 1 cubic centimeter. And notice we don't have to write the 1 here because anything divided by 1 is itself. So we can actually rewrite this as its own sort of rate. So we can rewrite this as 5 grams per cubic centimeter. 5 grams per cubic centimeter. And this is the answer to this problem. So, and notice that we can write the 5 outside because a fraction is the same thing as multiplication and then division. So our answer to this problem of what is the density per cubic centimeter, it is 5 grams per cubic centimeter. Now we are told that 240 liters of water flow out of pipe every 8 minutes. So per 8 minutes. I'm not going to attempt to draw this just so that you can get a better representation of kind of what's going on. Bear with me, I'm not an artist at all. So there's water flowing out of our pipe, and we want to know what is the flow rate in liters per minute or liters per 1 minute. And let's rewrite this as a fraction this time. So we have 240 liters per 8 minutes. Per 8 minutes. And now we want to get to 1 minute, so we need to divide this by 8. But another way to rewrite this is times 1/8 over 1/8. Because remember, if we have some number n divided by 8, that's going to be the same thing as n times. Remember, there's a 1 implied here, so this would be 1/8. So division by 8 is the same thing as multiplication by 1/8. So we're going to divide both, or we're going to multiply both of these by 1/8. Well, 8 times 1/8, or 8 divided by 8 is just 1. So we have 1 minute. And then 240 times 1/8, or 240 divided by 8. We can do that. So we have, well, first of all, what's 24 divided by 8? That would give us 3. And this extra 0 here, so that would be 30 liters. But just to make sure we can actually do this, so we have 8 into 240. And like I said here, 8 goes into 24 3 times. And then we can subtract. It's going to be 0, drop down this other 0. And then 8 goes into 0 times. So we have 30 as our answer. So our flow rate in liters per minute is going to be 30 liters per minute. Now we are asked, well, we are told that a car travels 300 miles. So I can rewrite that. 300 miles on 10 gallons of gas. On 10 gallons of gas. And we want to know the car's fuel efficiency in miles per gallon. So we can rewrite this already as miles per gallon. So 300 miles per 10 gallons. Per 10 gallons. And we want to find the number of miles per gallon, or 1 gallon. So we need to divide both of these, or we need to divide the numerator and denominator both by 10, which would be the same thing as multiplying both the numerator and denominator by 1 over 10. 1 over 10. 1 over 10. And dividing 10 by 10 will just equal 1, so we can scroll down a little bit. That would be gallon, 1 gallon. And then 300 divided by 10, well, we're just getting rid of 1 0, so that will be 30 miles. And this does look like what we're looking for, the fuel efficiency in miles per gallon. So this car can travel 30 miles with 1 gallon of gas. Let's do one more problem. So let's say that we're told a person's heart beats 4,200 times, so 4,200 beats per hour. per hour. And we want to know what is the BPM. So what is the BPM? And BPM stands for beats per minute. So in this problem, we're looking for the beats in a different unit of time. So we can rewrite this: 4,200 beats per 1 hour. And let's take note of the fact that 1 hour is equivalent to 60 minutes. So we can actually just rewrite this denominator as 60 minutes because the value of 1 hour and 60 minutes are the exact same. So we can rewrite this, and I'll change colors so it doesn't get as messy. So you have 4,200 beats per 60 minutes. And in order to get the BPM, or beats per 1 minute, we're going to divide both of these by 60 or multiply by 1 over 60 in both the denominator and numerator. So 60 divided by 60 is going to be 1. So we have 1 minute. And then the numerator, we're going to have to divide 4,200 by 60. So we can see 60 into 4,200. And to make this expression a little bit easier, we can actually just go ahead and divide both the divisor and dividend by 10. We can divide both the denominator, or we can divide both the divisor and dividend by 10. So we divide this by 10 and divide this by 10. Well, 60 divided by 10, we're just getting rid of 1 0, so that will be 6. And that's going to go into, 4,200 divided by 10. Again, we're just getting rid of 1 0, so that's going to be 420. So 6 goes into 4 0 times. 6 goes into 42 7 times. 7 times. And then 6 times 7 is 42. And now we can go ahead and subtract. Go ahead and subtract here. So 42 minus 42 is 0. We're going to drop down this 0. And then 6 goes into 0 times. So our answer to this problem, which this problem was giving us the beats per 1 minute. So we have 70 beats. So now that we know that the heart beats 70 times in 1 minute, that gives us the BPM. Notice that it's beats per minute, and here we have 70 beats, and the division bar is read as per minute. So that is exactly our answer. The BPM is 70. And we could have written 70 over 1, but because you're dividing by 1, it does not change the value. So we just write 70. So the BPM is 70. BPM is 70.